So this is one of the examples that that's in a RAM model. So the gray is our SSI, the black is the optimal throughput, the red is the estimate throughput, and the dotted blue one is the actual throughput. As you can see, the estimated throughput is very close to the actual throughput in our model, and in fact it's 90% accurate. So channel models. So we use three different types of changes in our SSI value. Most often occur for our channels model. So we use square wave, sawtooth, and the RAM. So sawtooth and RAM model represent the channels that is in mobile case. And sudden drop in RAM model correspond to the environment changes such as turning a corner or entering a stairwell. The square pulse model represents the fluctuating SSI value due to multipass. So the period defines how quickly the channels changes and hence insert the effectivities in rate algorithms. So we use the period of 625 milliseconds up to 50 seconds long. And the ratio of the maximum to minimum RSSI value is about 18 dB. So we use the result and to estimate a real life example. So this is a real example that we get the trace from a mobile user that is moving and becomes stable. And the gray again is our SSI value, the red is estimated throughput, and the blue dotted line is the actual throughput. As we can see, in the actual case, the estimated throughput also really close to the estimated throughput. So this is the value that we are using for different rate algorithms to estimate the throughput. The gamma up and down value and the delta up and down value for each algorithm. Then we use this matrix to compare algorithms. So as you can see, we can make general statements by looking at the alpha and beta value. If they're both greater than 0, then we said that A in general is better than B. However, if alpha is greater than 0 and beta is less than 0, then we said that algorithm A is better for those channels that shows rapid changes in optimal rates. For example, in mobile channels. If on the other hand, alpha is less than 0 and beta is greater than 0, then we said B is better for relatively stable channels where changes in optimal rates happen much more slow than the application times. So this is the result of three algorithms. The solid line shows the estimated throughput and the dotted line shows the actual throughput. As you can see, all three channels, square, sawtooth, and RAM, the estimated and the actual throughput, they are pretty close to each other. And also, this is the result of the comparison. And as we can see that the comparison using our model, they are pretty close to accurate. They are about 70% accurate. Conclusion. A simple formulations to compare different rate algorithms is developed. The formulations is about the inner work of algorithms. It is possible to make general statements for comparing different algorithms using the two metrics that we developed. And we're extending the evaluations to another algorithm and consider a non-linear fit for the transition period between two different times. Thank you.